Imagine a world where factories hummed with the relentless energy of steam, where coal-powered machines transformed landscapes overnight, and where the very rhythm of progress was dictated by the silent, powerful pulse of a piston. This wasn't the future, it was the present, forged in the gritty heart of the Industrial Revolution. But before this revolution truly took hold, the engines that powered it were inefficient, clunky, and barely functional. They were the work of Thomas Newcomen, a 1760s inventor whose steam engine could lift water from mines, but did so with staggering waste. It consumed vast amounts of coal to produce a mere fraction of useful work. The air in Birmingham workshops hung thick with coal smoke and the metallic tang of hot iron. Yet the engines struggled, their slow, laborious cycles failing to meet the growing demands of industry. This was the world James Watt walked into, a world where the potential for change was undeniable, but the tools to harness it were dangerously inadequate. Watt arrived in Birmingham in 1765, a young man with a sharp mind and an even sharper curiosity. He was not a factory owner, but a mechanic, working in the bustling workshops of the city where coal and innovation collided. His initial work focused on improving Newcomen's engine, a task that seemed almost impossible. The Newcomen engine operated by condensing steam in a separate chamber to create pressure, but this design wasted enormous amounts of energy. It required constant, manual intervention to maintain the condensation process, and its efficiency was a mere 1%. A fraction of what was needed to power burgeoning industries. Watt knew the old engines were dying. He saw the coal smoke, the laborers bent over broken machinery, and the slow, grinding pace of progress. He began meticulous experiments, not in a laboratory, but in the cramped, smoke-filled spaces of Birmingham's workshops. His hands, calloused from years of tinkering, traced the brass pipes and iron frames, measuring pressures and temperatures with instruments he had built himself. He was driven by a simple truth. Steam could be harnessed far more effectively than it was. By 1775, Watt had developed a revolutionary solution, the separate condenser. This was not a minor tweak, but a fundamental shift in how steam power worked. Instead of condensing steam directly in the cylinder where the piston moved, Watt designed a separate chamber where the steam could cool and condense without losing heat to the surrounding environment. This innovation drastically reduced energy loss, allowing the engine to convert more of the coal's energy into mechanical work. The result was a dramatic increase in efficiency, jumping from 1% to 10% steam output. This meant the engine could perform the same amount of work with far less coal, a critical advantage for industries that were rapidly expanding. Watt's breakthrough was not a single moment, but a series of precise, iterative improvements. He worked tirelessly for years, refining his designs until the engine could run continuously, without constant manual adjustments. His partnership with Matthew Boulton, a wealthy Birmingham entrepreneur, was pivotal. Boulton provided the capital and business acumen, while Watt brought the engineering genius. Their collaboration began in 1769, but it was the separate condenser that became the cornerstone of their success. In 1776, Watt secured a patent for his improved engine, a document that would become the blueprint for industrial change. The impact of Watt's work was immediate and profound. By 1778, Boulton and Watt had installed their first practical steam engines in Birmingham's textile mills, powering looms and other machinery with unprecedented reliability. The engines ran smoothly, producing consistent power without the frequent breakdowns that plagued Newcomen's designs. This shift was not just technical, it was economic. Factories could operate longer hours with fewer workers, reducing costs and increasing output. The steam engine became the backbone of the Industrial Revolution, driving the growth of factories, railways, and eventually, the entire modern world. Watt's engine was not just a machine, it was a catalyst for change. It transformed how energy was produced and used, shifting society from reliance on human and animal labor to mechanical power. The rhythmic clatter of pistons replaced the steady rhythm of hand-cranked machinery, and the coal smoke that once choked Birmingham's streets became the signature of progress. To understand the scale of Watt's achievement, consider the tangible difference. A single Watt engine could lift 100 pounds of water per minute, a capacity that Newcomen's design could barely manage. By the 1780s, these engines were powering entire industries, from textile mills to ironworks. The efficiency gains Watt achieved were not theoretical. They were measurable, practical improvements that directly impacted the lives of millions. His work in Birmingham was not isolated. It was part of a broader movement. The city became the epicenter of industrial innovation, where ideas flowed from workshops to factories. Watt's separate condenser was the key that unlocked this potential. It allowed steam engines to run at higher speeds and with greater precision, making them suitable for complex industrial tasks. This innovation was not just about efficiency, it was about scalability. A single engine could be replicated and scaled up to meet the demands of growing industries, a concept that would become the foundation of modern manufacturing. The legacy of Watt's work extends far beyond the 18th century. His improvements laid the groundwork for the steam engines that powered the early railways, the factories of the Industrial Revolution, and eventually, the entire machinery of modern industry. The separate condenser became a standard feature in steam engines for over a century, its principles still influencing engineering today. Watt's story is a testament to the power of focused innovation. He didn't invent the steam engine, he transformed it. He turned a flawed, inefficient design into a reliable, scalable tool that reshaped the world. The coal smoke of Birmingham's workshops, once a symbol of struggle, became the signature of progress. Watt's engine was the first true industrial machine, a silent force that would power the world for generations. The story of James Watt's steam engine improvements is not just a tale of invention. It is a story of human ingenuity in action. It reminds us that progress often begins with a single, focused idea, tested in the quiet spaces of a workshop. Watt's work in Birmingham, his relentless pursuit of efficiency, and his partnership with Bolton created a revolution that changed the course of history. The engines he perfected were not just machines. They were the heartbeat of an era, the silent pulse that drove the Industrial Revolution forward. They transformed how we work, how we live, and how we imagine the future. If you enjoyed this story, please like and subscribe for more amazing discoveries.